what are the different the types of investigations comes under this parts. So the first one is radiography under radiological investigation. The first one is radiography, then we have CT scan, mammography, angiography, then we have micturating cystourethrogram, then we have hysterosalpingography, then we have intravenous plelography, then we have retrograde urethroplasty, and then we have our DEXA. DEXA means dual energy X-ray absorptiometry. Now the different types of nuclear scan which are used are PET scan, the thyroid scan also obviously to study the thyroid. Then we have thallium scan to study the physiological function of heart, and this technetium based scan is used in tons of studies, like you take it as myocardium, you take blood, you take bone, you take lungs, you take liver, brain, all these organs are studied, all the physiological function of this organ is studied on the base of technetium based scan. Then we have the bone scan to study the proper, whether the mineralization of bone is proper or not, and then is a DEXA scan. Now let us move towards the non-ionizing investigation, and those are MRI. Here the magnetic field is used. Then we have USG, here the sound, ultrasounds are used, the sound waves are used. Then we have DEXA. Thermography was initially used, it's not preferred nowadays. Okay. Now let us move towards the electromagnetic spectrum. What is electromagnetic spectrum? It's basically a group of or a bunch of different frequencies which are together in a group. Like from here to here, the energy is increasing, the frequency is increasing, and the lambda is decreasing. This is the ionizing radiations, and these are the non-ionizing radiations. You are able to appreciate these are X-rays, gamma rays, then we have cosmic rays, right? And here we have radio waves, microwaves, infrareds, UV. So these are the non-ionizing radiation. So all the ionizing radiation and non-ionizing radiation as a part of electromagnetic spectrum. So they share some different similarities, and also they have difference between them. And those differences are, we all know, lambda, that means wavelength, then we have frequency and the energy. So they do share similarities, and those are, they don't have mass, they don't have charge, they have same velocity, that is 3 into 10 raised to the power 8 meter per second. Are you able to appreciate what this velocity is of which thing? It is of light, right? Then they are all photons, like X-rays and gamma rays are the photons. They are packets of photons which are moving in particular direction, whereas the alpha rays and the beta rays are the particles. Okay, oscillating particles. So we are going to see this in detail, what you mean by alpha, beta, X-rays, gamma rays. So just for till now, keep this thing in mind. Now let us see this ionizing radiation in detail. So what are the three types of ionizing radiations we have? We have X-rays, gamma rays, and cosmic rays. Cosmic rays does not reach us, so let us skip that part from our studies. So what we are left with? We are left with X-rays. So the first of all, let us talk about the mass and the charge. So both do not have mass and do not have charge. Okay, and now let us see this ionizing radiation in detail. So what are the three types of ionizing radiations we have? We have X-rays, gamma rays, and cosmic rays. Cosmic rays does not reach us, so let us skip that part from our studies. So what we are left with? We are left with X-rays. So the first of all, let us talk about the mass and the charge. So both do not have mass and do not have charge. Okay, and both are the traveling photons, right? And they both are the electromagnetic radiations. I will write ER for that. Electromagnetic radiation. Now the most important, that is what, without, instead of saying most important, we can say it is the only point of difference between the X-rays and the gamma rays. Otherwise everything is same. No charge, no mass. It is electromagnetic. It is a part of electromagnetic spectrum. It is ionizing radiation. It travels with the speed of light. But the only point of difference is that X-ray are produced by intranuclear generation, whereas gamma rays are produced by extranuclear generation. Okay, clear till now? Now let us move towards some of these subatomic particles. You know, the first one we know is electron, very famous electron, the negatively charged subatomic particle. Then we have the proton, the positively charged subatomic particle, and then we have our third, neutron. And let us add fourth one, the alpha particle. Okay, right? Now the beam of this X-ray, or the beam of X-ray passing in particular direction, we call it as beta rays. Okay, they are negatively charged beta rays. Now let us take two plates, okay, two parallel plates, one of which is charged positively and one of which is charged negatively. If we have electron here, obviously electron is negatively charged, and when it passes through this two parallel plate, it will deviate and accelerate towards the positively charged plate. So under the influence of electric field, this electron show acceleration. Same is the case with proton. Okay, so what happens if this is a proton P? So it is positively charged, hence it gets deviated and accelerated towards the negatively charged plate. So it shows acceleration. But when you put a neutral subatomic particles, that is neutrons, it will not get attracted towards positive plate or negative plate. It will not accelerate. It will go in straight path between those two parallel plates. It will go straight. Okay, it does not show any acceleration. Now one more point you guys need to know is that, wait a minute, let me guess this, is that hydrogen atom contains only one electron. When you knock off this electron, so this electron get knocked off, it is left with one positive charge, and hydrogen with one positive charge, you call it as a proton. So what is proton? It is a hydrogen with one positive charge, and it exhibit, it is a MCQ asked, frequently asked MCQ, it exhibit Bragg's peak. Okay, just keep this in mind. They ask which of the following exhibits Bragg's peak. Those are protons. Then we are left with neutrons. They does not accelerate and they do not have any charge. Now the alpha particles. What do you mean by alpha particles? Alpha particle is basically helium, but with two positive charges. Helium has two electrons. When two electrons get knocked off, you are left with helium and two protons, two neutrons. So we call it as alpha particles. Okay. Now let us move towards the types of investigations you have in the radiological imaging on the basis of whether it is invasive or non-invasive. So we have investigation. Okay, we have invasive, and then we have non-invasive. See, whenever you think of different radiological imaging techniques, you can't differentiate whether it's only invasive or only non-invasive. There is other two categories we call it as micro-invasion and minimal invasive. So let us move towards the invasive part. So let us arrange these different types of investigation in decreasing order of invasiveness. So the first one we are with is laparotomy. Ectomy. So it is a maximum invasive. It is invasive. Right? Now the second group we are talking about is laparoscopy. Then we have arthroscopy. Other type we have is catheter angiography. So all these techniques are minimally invasive. Minimal invasive, it's like just a mere some of cut is used for the imaging, proper imaging of through these techniques. And then we are with, let us take the green, we have CT scan, we have CT angiography, or we are left with PET scan. So what happens here, the radio-opaque dye is introduced in the body and then the imagings are taken. So the invasiveness is as low as just a prick through a needle. So it is micro-invasive. And then we are left with the USG. It is non-invasive. It's just a probe kept on the skin, no cuts, nothing, no invasion. So these are the decreasing order of invasiveness. So here are some points. Once you go through it, like let's read together. The rays with highest penetrating power are the gamma rays. Then the ray with highest damaging power is alpha rays. Then the rays with highest mass is alpha rays. Obviously, because alpha rays is helium, dipositive helium atom. The rays with highest ionizing potential, alpha rays, because since it is high damaging power, because it ionizes the material very too much as compared to others, so it causes damage higher than other. Then we have highest biological effect. Obviously, it is causing damage to the body. It will be alpha rays. The highest linear energy transmission, I just discussed energy. Higher the energy, higher the damage. Higher the energy, higher the charge imparted. So alpha rays. Just keep one point in mind. Every highest is alpha rays. Okay, alpha rays. Only the highest penetration power we are left with the gamma rays. Okay. Read this and try to learn it. These are very important MCQ, frequently asked in the exam. So here we are done with the radiation. Now let us move towards the individual, individual imaging techniques in detail.